Shreyas, do you mind speaking a bit about your background and how you moved towards NFE, just the timeline there?
Yeah, so I have a PhD from Georgia Tech back in 2011, and during my PhD I learned radio, how to make radios lower power and more intelligent. Today I build smart radios. From there, 2011 to 2015 end, another 4.5 years I was at Intel Research, and I was part of a 10 people team who pioneered the first USB-C connector. And that has sold 2 to 3 billion devices today. That started me dreaming that someday I want to come up with some technology. Hopefully that would sell in billions, right? But looking for freedom, more academic freedom. Back in 2016, I joined Purdue University, where I started my own group and research. And the 5 years each experience of wireless and wireline had taught me that there is 1,000x more efficient communication that you can do when you can confine energy within a wire. Which then led to asking the question that can the human body be used as a wire, or can you confine energy around humans and that way communicate? Which led to the invention of the YR technology. And then the company Ixana was founded and to commercialize this technology. We started this YR body radio network band technology starting from CES 2023. We have been demonstrating, and we got the CES Best Innovation Award in 2024, and then we have the Silicon 100 Award and things like that. Silicon 100 inclusion, I should say. But as we are progressing, then we realize that the electric dipole that we're utilizing to excite the body can also communicate among each other through free space or through any dielectric material. And that understanding led to this near field electric technology, which is the dual field of near field magnetic, which is what we call NFC. In there you are creating the magnetic field and it goes this way and you pick up with another coil. But instead of that, you can excite with 2 electrodes and create an electric field bubble, and that bubble can be picked up with another 2 electrodes, which creates a dipole. And that really has led to today we are launching at CES the wire NFE, which is 5 megabits per second, which is 10x higher speed than NFC, as well as longer range. It is decimeter range, tens of centimeter, as well as much lower energy per bit compared to NFC, at least 50x or more better in energy per bit.
And could you talk a little bit more about the security behind the chip and your background as well in PQC, post-quantum?
Correct. So security, we have been playing with 2 kinds of security. One is physical security, which is inherent to the physics, and we say privacy by physics, or the physical security part. I will explain that first. And the second part is the mathematical security, which is the encryption. And I'll explain that second. So physical security means, when you have radiative fields, where electric field and a magnetic field affect each other, it just gets radiated out, and then the signal drops at 1/r square. That's it. So it goes everywhere and you can pick it up. Whereas when you excite only the electric field and no magnetic field, then it cannot affect each other. It just stays confined to the conductor surface, and it drops at 1/r to the 6, which basically creates a bubble that does not radiate out. And if you're doing communication there, that signal cannot be picked up from far away, giving the physical security. This is inherent to E-field communication, be it the YR band, where that bubble is around the human, or within YR NFE, where the bubble is around the 2 devices, like 2 phones. If I'm communicating, there's a bubble and bubble here, and somebody a little bit far away cannot get that. So this is the physical security part. On top of that, since my Intel days, I have been working with the Intel Security Research Group, and then at Purdue, I have been funded from Intel and other NSF on security research, which has led to us building single chips which had AES and YR-like communication in it there, which then led to later getting involved in PQC projects with Purdue and KU Leuven in collaboration with Intel that developed the first post-quantum cryptography ASIC in the world.
So you've developed the first post-quantum
ASIC in the world. This is in the 2021 time frame. And this was part for a technology called Saber, which was one of the 4 NIST PQC finalists.
Okay.
It did not win, the Kyber won,
Okay.
but the building blocks were very similar
Okay.
between Sabre and Kyber.
Mm.
So from there, we have a lot of PQC IP, and now this year also at ISSCC in February,
Yeah.
we will be demonstrating the lowest power PQC chip, another advancement in PQC
Okay.
that will be launched in February in San Francisco.
Okay. Okay.
So we have done the first, and now we have the lowest power as well.
Yeah.
And there are other.
Is that enabled by NFV technology or?
No.
No.
So like I said, NFE gives you the physical security,
Yeah.
and PQC is adjacent to it,
Right. Okay.
which gives you the mathematical security. But in the same platform, both of them needs to be there to give you both the physical and the mathematical security. Initially, probably within the same package or within the same platform, and probably later, like we have a test chip where within the same die.
Okay.
So these go in hand, but are two fundamentally different enabling technologies.
Understood. And we had that demo today where the chips were embedded in the phones, and we did a transfer of the image, which we'll show.
Okay.
Is there anything else that you'd like to say before we close out here?
So the other part would be the other demo we have where we can send, from the body-assisted NFE, giving you longer range, or send information by just touch. So like you have a watch, I have a watch, and if we fist bump, I can send a business card or a secret message
Yeah.
in an instant.
Yeah.
We also have the demo available, so that is something. So you saw the pure NFE demo integrated into phones, but the body-assisted NFE demo is also available.
Okay, great. Well, thank you so much.
Thank you.
It was so great learning about all the new technology. I'm very excited to see where Ixana goes with